And now that we've learned about high availability and clustering, we're going to talk about how this relates to virtualization. In most cases, we're probably not going to be running the vast majority of our infrastructure on physical machines anymore. They're mostly virtualized. So we're going to talk about how to do that. So there's two things that have to be highly available. Number one, the servers that are hosting Hyper-V should be high available with failover clustering and so forth. But also the virtual machines themselves should have high availability. So we'll talk about how to do both of those in this unit. So first, let's talk about making sure that Hyper-V is highly available. So we can configure a highly available clustered virtual machine by creating a failover cluster on computers that are running Hyper-V, the Hyper-V role. So it's really not unlike what we've already discussed with network load balancing and failover clusters. It's just that now the service for the failover cluster is going to be Hyper-V. So basically, we're going to create our servers. We're going to install the Hyper-V role on the physical server, and then follow all the steps that we talked about for creating a failover cluster. But again, the role for which we are doing failover clustering is going to be Hyper-V now instead of some of the other things that we talked about. So to create a highly available VM or virtual machines, you're going to follow these steps. So first, we're going to verify that we have two host computers that meet the requirements for the Hyper-V role and failover and clustering features, because we need to install both of those, the Hyper-V role and the failover clustering feature. We're going to be sure that all the host computers are members of the same domain. And we're going to install Hyper-V role and failover clustering feature on all of the servers participating in the cluster. Then we're going to configure the shared storage and failover cluster that the failover cluster will use, just like we configured it before. Same thing, with shared storage. And then in Hyper-V Manager, we're going to configure the virtual networks that the VM is going to use and validate the failover cluster configuration by running a validate configuration wizard, which we looked at actually before. So we kind of looked at this before. So again, none of this is really terribly different than what we did before. There's a few special considerations when we're talking about virtual machines. Finally, we're going to create the failover cluster, and then we're going to add storage to that cluster's shared volume if you're going to use CSVs, which, as we discussed before, is the recommended way of doing this, using those CSVs, the shared storage volume. So and by the way, the shared storage volume is for all of the stuff that we're sharing between these two VMs in the cluster, or multiple Hyper-V instances in the cluster. So using the failover cluster manager, which configures a VM for higher availability automatically. So we're going to start the new machine wizard, or the new virtual machine wizard. We're going to click the roles node in the actions pane, and then click virtual machines, and then new virtual machines. So this is how we create our new virtual machine that's highly available. So in the first window, you're going to choose the target cluster node for the VM, and from that point, you'll install the VM just like you would on any other machine. So it really isn't any different once you get this configured. I haven't really given you details yet, so let's talk about how to configure an existing VM for high availability. So if the VM already exists, you're going to move it to the shared storage using the move option in Hyper-V Manager, which we're going to talk about here at the end of this unit. Then you're going to configure the VM for high availability in the failover cluster manager, and then you're going to click the configuration role in the actions pane to start the high availability wizard. And then in the select role window, you're going to click virtual machine, and then one or more of the VMs and continue the wizard. So drain on shutdown basically is the way that drain on shutdown works is if you have to shut down Hyper-V, instead of shutting down all of your virtual machines. So by default, if you install Hyper-V on a server and you've got 4 or 5 VMs running in Hyper-V, when you go to shut down that server, it's going to shut down all of your VMs. Instead, when you have a cluster, if you're going to shut down a machine that's hosting a bunch of VMs, instead of just shutting down all those VMs, instead it will move them to another host. So it'll automatically transfer control of those VMs to someone who's still online and then shut itself down. So you don't lose those VMs whenever you shut down a machine or if the machine shuts down for some reason. So it'll more elegantly move those machines over for control to another VM. You can also configure monitoring for your virtual machines. So with virtual machine monitoring, you can monitor the resources, applications, and services all running in highly available VMs. So some of the prerequisites: the guest operating system in the Hyper-V must be running at least Windows Server 2012. The guest OS has to be a member of the same domain as Hyper-V, so everyone has to be on the same domain. The user running the failover cluster manager must be a member of the local administrators group in the VM guest OS. Okay, so configuring the machine monitoring, you're going to configure VM monitoring. You need to enable VM monitoring firewall rule on each guest to be monitored. That way, because it uses TCP, so it's going to need access to the machine. So from the firewall control panel, you're going to allow an app or feature through Windows Firewall, and then you're going to select VM monitoring rule, which will make the domain make sure that the domain checkbox is selected. So in the FCM on the VM's host machine, you're going to click Roles, right-click in the VM to monitor, point to More Actions, then click your monitoring, and you'll be able to monitor whichever services you select on that machine. So if monitoring service is determined to have failed, a service restart is attempted up to 2 times by default. If the service fails to start after the second attempt, an event ID of 1250 is generated in the system log, and then the VM is automatically restarted. If another failure occurs, the VM is moved to another cluster and started. The VM failure response policies can be changed in the cluster manager. So again, this is basically how you configure what to do in the event that a failure is detected, either a failure of the service or a failure of the server itself. So you can also use VM network health detection. So it's network disconnect is detected on a VM's virtual NIC. The cluster moves the VM to another cluster node, and VM network health detection is configured in the network interface in each VM. So to enable or disable it, you're going to open up the settings in VM and Hyper-V Manager for the failover cluster manager. Click to expand the network adapter, and then you're going to click Advanced Features and click Enable or Disable the Protected Network checkbox. So again, this is to automatically detect if there is a network failure on a virtual machine, so it'll move it to a new host to try to resolve the network failure. All right, guest clustering. So once we have our, now again, the steps that we've taken so far is we would have created, we have created a failover cluster just like we discussed previously in the course, and Hyper-V is one of those services that can be supported through failover clustering. And when we built our VMs, then our VMs were basically in that, within that failover cluster with Hyper-V. But the thing is, we still probably only have a one VM for a particular service. They're not actually clustered. This is an interesting question, though, is how far should you go with your clustering? Theoretically, if you have a highly available Hyper-V cluster running, and you have your virtual machine running within that, it would stand to reason that that machine, by just by association with Hyper-V, is already highly available because it'll automatically get moved when there's a failure. It's gonna monitor it, all the other stuff that we just talked about. But generally, it's best practice to also use high availability with the actual VMs. As I said before, there are third-party tools to do this. So there are devices you can purchase and appliances that can do this load balancing and clustering for you with Windows, but you can do this natively, and this really isn't all that different from clustering for the server. So now we're talking about 2 layers of clustering. There's clustering happening at the Hyper-V level in the operating system from which Hyper-V is running, and then we can also do clustering of the individual virtual machines, so we can have multiple virtual machines that are clustered. So basically, we're using failover clustering in the VM's guest operating system. So you can monitoring. Some of the benefits are monitoring clustered resources in the guest OS, Hyper-V host optimization, and host failure protection. So to create a guest cluster, you're going to follow the same procedure as for creating a failure cluster with physical hosts, just like we talked about before. So a guest cluster can use a shared virtual disk instead of a traditional SAN storage. So this is one of the big differences with virtual machines. With physical machines, we had to have a shared SAN, right? We had to use iSCSI and have a shared volume, so we use CSV to do a shared volume for clustering. But with virtual machines, we can use the storage mechanism within the virtualization. So Hyper-V can kind of give us a layer of, reduce that layer of complexity because it's already a shared disk, right? So the way Hyper-V works, everyone's already on a shared disk. It has the ability to do that for us. So you can kind of work around that step a little bit. So the steps for configuring a 2-node guest cluster would be to configure the Hyper-V failover cluster as I just described. Then you would create 2 highly available VMs, and then you install Windows 2012 R2 on both VMs, and then join each VM to an Active Directory domain. Install the failover clustering feature on both VMs, and then make sure that both VMs have access to the shared storage. create the guest cluster, and add both VMs to the cluster. So again, this isn't really all that different from creating a failover cluster in a physical machine. It just happens to be a VM, and the storage is a little bit different. But other than that, the steps are very similar. So to create a shared virtual hard disk with your guest cluster, you have to have the following requirements. So you have to have configured Hyper-V failover cluster as I described previously. So your Hyper-V failover cluster is already configured. It's already using a CSV that you've already created. You're using clustered shared volumes, which is CSVs, or a share on a scale-out file server to store the virtual hard disk, one or the other. The guest operating system on all clustered modes must be running 2012 R2 or newer, and the shared virtual disk must be connected to a virtual SCSI controller and be in the VHDX format, which we haven't really talked about Hyper-V too much in this course, but in the previous course we discussed Hyper-V, so most of you should be familiar with what the VHDX format is, but that's just a format for a virtual machine disk. All right, in the last slide deck, I'm going to discuss VM movement, how we move VMs from one machine to another.